Hello friends, myself Rajendra Mahajan presenting my one more video on Fourier series for even function. Let us solve the problem. Obtain Fourier series for the function f of x is equals to x into sine of x in the interval minus pi less than x less than pi. Important example as exam point of view. Therefore, once again I will repeat the question. Obtain Fourier series for f of x is equal to x into sine of x in the interval minus pi less than x less than pi. Watch the video up to end for better understanding. Here the range or the interval is minus pi to plus pi, means we can check whether the function is even or odd. And therefore, given f of x is x into sine of x. I have explained this example in detail with step-by-step calculation. F of x is given as x into sine of x. Replacing x by minus x on both the side, we get f of minus x as left hand side is f of minus x, right hand side becomes minus x sine of minus x, and all we know that sine minus theta is minus sine theta. Therefore that minus and the previous minus, it becomes plus. Therefore term becomes x into sine of x, means same function. And as we get same f of x, the given function is an even function. Or another way, x is an odd function, size x is an odd function, a product of two odd function is even function. This is an even function in the interval minus pi to plus pi. And therefore, Fourier series for even function, is obtained by or given by the formula. Formula is f of x is equals to a0 by 2 first term is a0 by 2 plus summation of an into cos of n pi x by L, n changes from 1 to infinity, and we call this as equation number 1, where Bn is 0 as it is even function, and we require to find these two Fourier coefficient a0 and an. a0 is obtained by or given by, formula is 2 by L integration from 0 to L of f of x and its integration with respect to x. Here the value of L is pi, as it is from minus L to L type of interval. L is pi, and therefore substituting the value, we get a0 as 2 by pi integration from 0 to pi, f of x is x into sine of x and its integration with respect to x, and as it is a product of two terms of x, we have to integrate it by a generalized part. Already I have mentioned in previous example also, for Fourier series, that integration by generalized part plays very important role for evaluation of the integral. Therefore, we have to decide order x algebraic, therefore first term, and sin x as second term. 2 by pi as it is outside. First term x, integration of sine is minus cos n x, cos x, sorry, divided by 1, then minus derivative of x with respect to x is 1, and next integration of cos is sine with that minus sign, therefore it is minus sin x, and limits, next term becomes 0 as it is constant term, derivative of constant term is 0, limit from 0 to pi. Substituting the upper limit, we get 2 by pi as it is, no change, minus pi cos of pi, and minus minus it becomes plus sin pi. These two terms for the upper limit, minus lower limit, when x is 0, first term becomes 0, and sin 0 is 0, therefore second term also 0. And then simplifying it further, we get 2 by pi. The value of cos pi is minus 1, and therefore that minus pi into minus 1, sin pi 0, pi get cancelled, we get that value of a0 as 2, equation number 2. This is the first Fourier coefficient, equation number 2. Then we have to obtain the value of an. Formula is 2 by L, integration from 0 to L, f of x into cos of n pi x by L capital, and its integration with respect to x. Substituting value of L as pi, 2 by pi, integration from 0 to pi, function is x into sin x multiplied by cos of n pi x by pi. Pi get cancelled, we get only cos of nx. And its integration with respect to x. Simplifying it further or rewriting it, we get 1 by pi. 2 we are taking inside that integral sign, x as it is, multiplied by 2 sin x into cos of nx. This product of two trigonometric terms we convert into sum by applying defactorization result. We know that 2 sin a cos b as sin a plus b plus sin a minus b. Using that formula, we have 1 by pi as it is, no change, integration from 0 to pi, x multiplied by it is sin a plus b, means sin of x plus nx, and plus sin of a minus b, means it becomes sin of x minus nx, and then its integration with respect to x. In next step, we multiply by x inside the bracket and write down two separate integrals. Therefore, 1 by pi as it is, no change, in bracket, first integral from 0 to pi, x multiplied by sin of, taking x common, we get 1 plus n times x with respect to x, and plus second integral as x into sin of 1 minus n times x, and for simplicity we call the first one as I1, and second one as I2. Therefore, it becomes 1 by pi multiplied by I1 plus I2. We call this as equation number 3. Numbering is very, very important, where we have to obtain the values of I1 and I2, where I1 is given by integration from 0 to pi x sine of 1 plus n times x, and its integration with respect to x. Again, it is product of two terms, therefore integrating it by generalized part. And whenever we have to perform by generalized part, by applying LIAT rule, we decide the order. Therefore, x must be the first term and sine must be the second term. First term x, then integration of second means integration of sine as minus cos of 1 plus n times x and whole divided by 1 plus n minus derivative of the first term, derivative of x is 1. Next integration of cos is sine, but with that minus sign, therefore it becomes minus sine of 1 plus n times x and whole divided by 1 plus n whole square. Next derivative becomes 0, we stop here, and limits from 0 to pi. Lower limit 0, upper limit pi. Substituting the upper limit first, we get it is minus pi excess pi cos of pi plus n pi if we multiply it inside and divided by 1 plus n. Calculations are very simple if we go step by step. And plus sine of pi plus n pi whole divided by 1 plus n whole square. And for lower limit, as x is 0, that term becomes 0, and sine 0 is 0, therefore second term is also 0, means for lower limit we get 0 plus 0. Simplifying it further, for that we have to apply the standard trigonometric result. We know that sine pi plus minus theta, sine of pi plus theta and pi minus theta. For plus we get minus sine theta, and for minus we get plus sine theta. And similarly for cos pi plus or minus theta is minus cos theta, means for both we are getting minus cos theta. And therefore applying this result for further simplification, minus pi as it is, no change. Cos pi plus theta is minus cos theta, means minus cos n pi. Calculation must be error free, then only we are getting the correct answer. And whole divided by 1 plus n. And sine pi plus theta is minus sine theta, means it is minus sine n pi whole divided by 1 plus n whole square. Lower limit 0. Then minus minus it becomes plus. Pi, value of cos n pi is known to all of you as minus 1 raised to n upon 1 plus n, and sin n pi is 0. And therefore cos n pi is minus 1 raised to n. All that standard results I have written in some with different color, so that is easy to remember. I1 is equals to pi minus 1 raised to n divided by 1 plus n, and we call this as equation number 4. Similarly, we have to obtain the value of I2. It is integration from 0 to pi x multiplied by sine of 1 minus n times x. And then again follow the same procedure, integrating it by generalized part, considering x as the first term and sine as second term. As algebraic, x must be the first and sine is trigonometric, therefore it must be the second. Therefore first term x, integration of sine is minus cos of 1 minus n times x and whole divided by 1 minus n, coefficient of x. Then minus derivative of x is 1. Next integration of cos is sine of 1 minus n times x with minus sign as it is, and whole divided by 1 minus n whole square. Limit from 0 to pi. Subtracting the upper limit, we have minus pi cos of pi minus n pi whole divided by 1 minus n, and minus minus it becomes plus sine of pi minus n pi upon 1 minus n whole square, and once again using the upper results written in green color. Lower limit x0 0 sine 0 0. Cos pi minus theta is minus cos theta, therefore it becomes minus pi into minus cos n pi whole divided by 1 minus n, and sin pi minus theta is sin theta, means sine of n pi divided by 1 minus n whole square, and then subtracting the value of cos n pi and sin n pi. Sin n pi 0, cos n pi is minus 1 raised to n, therefore that minus and this minus will become plus pi minus 1 raised to n whole divided by 1 minus n, sin n pi 0, and therefore this is the next equation. Pi I2 is pi into minus 1 raised to n whole divided by 1 minus n. Equation number next, 5th. Yes, it is equation number 5th. And then substituting values of 4 and 5 in equation 3. Put equation 4, equation 5 in 3. Means using the values of 4 and 5 in equation 3. That equation 3 is an is equals to an is equals to 1 by pi as it is. The value of I1 is pi multiplied by minus 1 raised to n whole divided by 1 plus n. This is the equation number 4th. And 5th one is pi minus 1 raised to n and whole divided by 1 minus n. From these two terms we can take pi into minus 1 raised to n common and whole divided by pi. And then cross multiplying, we get 1 minus n into 1 means 1 minus n, and plus 1 plus n, and product of a plus b into a minus b is a square minus b square. As per that it becomes a square means 1 square b square is n square minus n square. Plus n minus n get cancelled. Pi get cancelled. And we get 1 plus 1 as 2 multiplied by minus 1 raised to n and whole divided by 1 minus n whole n square. Equation number next 6. If we observe the term in the denominator, it is 1 minus n square. When we put n is equals to 1, it becomes 0. Means we have to impose the condition that n should not be equals to 1. And we call this as equation A. And then put n is equals to 1 in that equation A. We get the value of A1 separately. See, this is that equation A. Therefore, when we put n equal to 1, we get 1 by pi x multiplied by sin x. 2 I have taken on inside, therefore it is 2 sin x into cos of nx. N is 1, therefore it becomes cos x. 1 by pi as it is. And then we have to integrate it with respect to x. But we know the formula from trigonometry. 2 sin theta cos theta is nothing but sine of 2 theta. And therefore it is x into sine of 2x. Though it is lengthy, but not difficult to perform the calculation if we perform step by step. And give the results as a supporting statement. Therefore 1 by pi as it is. First term is x. Integration of sine is minus cos 2x whole divided by 2. Then minus. Derivative of x is 1. Next integration of cos is minus sine 2x divided by 2 to the 4. And next derivative becomes 0. Therefore we stop here. Limit from 0 to pi. 1 by pi as it is. Substituting the upper limit, we get minus pi cos of 2 pi and whole divided by 2. And minus minus it becomes plus sine 2 pi and divided by 4. And for lower limit, as x is 0, that term becomes 0, and sine 0 is 0. Therefore both the terms are 0. And then using the value of cos 2 pi and sine 2 pi. Cos 2 pi is 1. Therefore we get minus 1 by 2 into 1. Sine 2 pi is 0. Lower limit is 0. Therefore the value of A1 is minus 1 by 2. Equation number next 7. Therefore, substituting the values of A0, A1 and An in equation number 1 means the formula of Fourier series. Bn is 0 as it is even function. Therefore, f of x is here x into sin x is equals to a0 by 2. A0 is 2 divided by 2. A1 is minus 1 by 2 into cos of x. For n is equals to 1, we get cos x. And then write the summation for the remaining values. Therefore, summation from 2 to infinity. Value is 2 into minus 1 raised to n divided by 1 minus n square into cos of nx. Simplifying it further, we get x into sin x is equals to 2 by 2 means 1 minus 1 by 2 cos x as it is, no change. and 2 we take outside the summation sign. Therefore, plus 2 times summation of minus 1 raised to n upon 1 minus n square into cos of nx. N changes from 2 to infinity. This is the required answer. Or this is the required Fourier series for that given even function. Therefore, watch up to last step. Then and then only you will understood the basic concept behind this problem. Please like my video, share it, as well as subscribe to my channel, and to receive the notification for such type of new videos, please press the bell icon. Thank you. Thanks for watching.